Hey guys, back problem number 3, week number 4, 1 mark problem here. Let the Maclaurin series for tangent be the following. Tan x equals a1x plus a3x cubed plus a5x to the fifth, where a1, a3, and a5 are constants. Find the series for secant squared in terms of a1, a3, and a5, up to and including the x to the fourth term. Okay, so 1 mark should be some pretty simple algebra, but we know that the derivative of tangent is equal to secant squared x. Okay, therefore secant squared x should be equal to the derivative of the Taylor centered at 0, which is a Maclaurin. Okay, so a Maclaurin series representing secant squared x should be a1 plus 3 a3x squared plus 5 a5x to the fourth. Cool. So we're just taking the derivative of a quintic polynomial, and that's our answer. Okay, so for part B, find a series for secant squared in terms of 1 through a1, a3, and a5, up to and including x to the fourth term by using the relationship that secant squared x is equal to 1 plus tan squared x. Okay, so we're not going to be using the previous method. We did that just to show that we could. But if secant squared is equal to 1 plus tan squared, then in terms of the Maclaurin series for tangent, which was a1x plus a3x cubed plus a5x to the fifth, and on squared. We could do a little bit of algebra on that. Now, because I only want up to the x to the fourth term, I can simplify the issue here and make this slightly easier to understand. I'm just going to write this as a1x plus a3x cubed. I'm going to drop the rest of the Maclaurin series because any term beyond that will go past the x to the fourth term. Okay, so let's quick FOIL this thing out and neglect anything that goes above the fourth degree term. Okay, so if I FOIL this, that's like a1x plus a3x cubed times itself. Now I won't have to do the L in FOIL because that will go beyond an x to the fourth term. So I'm going to have a1 squared x squared plus 2 a1 a3 x to the fourths. Okay, I'm neglecting the last term, which would have been a3 squared x to the sixth. Getting rid of that term clearly because that's going to go beyond a fourth degree polynomial then at that point. So secant squared x could be represented using the following. And IB is so creative on coming up with different ways to present these problems that it gives you a good, just a good overall grasp on where you're at. Okay, so let's move on to part C and see how they have us use that. Hence, by comparing your two series, determine the values of A1, A3, and A5. Okay, so this is kind of cool. They're going to utilize what we know. Okay, so I'm going to take what we found out from part A, which was A1 plus 3a3x squared plus 5a5 x to the fourth, and set that equal to 1 plus a1 squared x squared plus 2a1 a3 x to the sixth. Oop, I'm sorry, x to the fourth. That's why I shouldn't have done that on the last problem. Okay, so now what we can see, guys, is that the constants must be the same. Therefore, a1 must equal 1. The coefficients of x squared must be the same. Therefore, 3a3 must be equal to a1 squared. Therefore, 3a3 must be equal to, we know a1 is 1, so that'll be 1 squared, which is 1. So a3 will be equal to 1/3. Okay, I got a3, I got a1, now I just got to find a5. So 5a5 is equal to 2a1 a3. So 5a5 is equal to 2a1, which was 1, a3, which was 1/3. It looks like a5 will be equal to 2/15, if I'm not mistaken. And there you have it. So if we go all the way back to the beginning, secant squared x, its Taylor, will be equal to 1, it's Maclaurin, or Taylor centered at 0, will be 1 plus, what would that be, 3 times a3 x squared plus 5 times a5 x to the fourth, which would be 1 plus x squared plus 2/3, I believe. Yep, 2/3 x to the fourth. That would be a Maclaurin series for secant squared. That's pretty cool. Again, just getting creative there, seeing how well you know what you know about series. All right, that's it for question number 3. Fire away on those questions if you got them for me. See you in the next video.